to do based.
Yeah, I mean, part of the problems with as we also have discussed is overfitting, right?
Hmm.
So basically, what you do, you estimate parameters, and you use these parameters to predict with. But in Bayesian machine learning, the parameters are random variables.
Okay.
So you actually get a distribution over parameters, and that then you can integrate the parameters out, so you completely eliminate overfitting.
Okay.
So you get something that only depends on the observations. So it depends on the model you choose. I mean, how many, if you take deep learning, how many layers and stuff you choose, but you don't. It doesn't depend on the parameters.
Okay.
So that's a yeah, that's a really
That's pretty interesting.
yeah, it is. It
But
is.
then how do you solve for Neil? Do you use still approximate methods or?
Well, I mean, you put a prior distribution over the parameters in, say, in a neural network, and then you use Bayes theorem to compute the posterior distribution,
Mm-hmm.
and then you can use the posterior distribution to integrate out the parameter. So you got a predictive distribution.
Mm-hmm.
It only depends on the observations. There's a lot of integration and there's a lot of math in it, so it's not particularly easy.
And I was wondering, like, in your the Jupyter notebooks, there's a lot of functions which are not very easy to understand. So do you expect people to go through each function and understand exactly what they are doing, or you want?
Well, I mean, eventually people should be using. I mean, these because they're vectorized, they use the vector operations in Python, and that makes the code much faster.
Mhm.
And so instead of using